Hi
You're
Mario,
here.
how are you?
Tired, but good to be here.
Hi everyone. Tonight, evening, or today, because the global YouTube live now, and we would like to introduce you, Professor Mr. Mario Carpo. He will join us for this podcast. Mario Carpo is an architecture historian and critic and is currently the inaugural Rainer Banham Professor of Architecture, History and Theory at University College London. And he did many things. He's a global guy. He's a Mediterranean, Italian, Londonese, and also the New Yorker. He's everywhere. And I would like to give you the research summary about the areas of specification, history of architectural theory and history and cultural technologies with focus on the early modern period, means the Vitruvian tradition and Italian Renaissance from Alberto to Vignola, and then on contemporary digital design theory, 1990 to the present, today, theory and criticism of contemporary architecture. We know him, the last book, second digital turn, it was a legend book. Everybody has it, right? Everyone has has it. And you can see he did many search and theoretical some works and also some the text about the different kind of architects and situation, and especially he is very important for today, understanding where are we now, especially I don't want to add the post-COVID, but maybe you can add something about the post-COVID. Today is very famous topic, and then you can see the many. He is not stopping. He everywhere, every day. He is doing something, and then and also he creates not only the text, also the sense of humor, some jokes about our architecture field. And
That's it.
I would yeah, I would like to leave to him. He has some presentation. Let's say not exactly the presentation. There's some not the serious presentation. Also some jokes, I think. In my opinion,
That's
it's a
right.
good. Okay,
That's right.
we are listening to you. The,
Okay.
how are you? How is London? How are you? And how is your university, your students, your life, your
You
girlfriend?
were asking. I do something every day, and you would be amazed at the number I've learned. But I had to learn to do for the last 2 months because due to we call it the lockdown, the fact that you have to be segregated at home. So a number of services we are used to depending on have disappeared. So for example, at my age, for the first time, I had to learn to iron my laundry, because there is no one, all the laundries are closed. I had a maid who came once a week to do basic work in my apartment, but she's an elderly lady. I couldn't ask her to come. Besides, during the lockdown, it was illegal. So I'm still paying her, but she's not doing anything. She's not coming.
And
So I have to.
you changed your style.
Well, I'm not wearing a shirt, as you may notice, because I'm at home. So that's, I'm actually in my pajama, but you're not going to see that. But still, even that needs ironing. So I need to iron, etc., etc. But so many things have changed for the last 3 months. And I remember the last time I was, which was also the I was at your place almost 2 years ago. Occasion we had, which was, and it is now on YouTube or something. And so there are things we said 2 years ago, which we could still say, things that haven't changed that much. There are things I was telling my students when I last had class in a physical building in mid-March, and things I was saying on that day, I could still repeat them today because many of them are still good. Many things have not changed, but many have changed because the global pandemics and the catastrophe which has swept across the globe just destroyed economies and upturned our societies. I just asked to reassess the way we look at the world, our worldview, the way we look at life, the way we look at architecture. And we have all been doing that for the last 2 months. And so some of our arguments and hypotheses and theories have actually been corroborated, reinforced, validated, even vindicated by the pandemics, but some have not. So we have to reassess and reevaluate. And besides, this is what I could have told you 2 weeks ago or 3 weeks ago. But for the last 2 weeks now, there is another additional factor to be taken into account. I don't know to which extent this has been in your part of the world, but it is quite significant here in London, in the United Kingdom, starting with the Black Lives Movement in America, which has spread to many Western countries, but not all of them, only some of them. And it is, in my opinion, one of the most potent, inspirational, influential, popular movements I have seen in my lifetime, from when I was a teenage student in Italy in the late 70s, at the time of the Red Brigades. I remember that time vividly. It doesn't compare, or perhaps to some extent it does, because one of the reasons, not the only reason, but one of the reasons why the global anti-racism movement is so strong and powerful and inspirational is precisely because it is taking root in countries which have been devastated by pandemics, which are still, paralyzed by the pandemics. In London, we are still basically under lockdown. There are strict rules indicating what we could do if we go out, how many people we can meet, I think maximum 6, which distances we should keep, I think 2 meters. And then every day in the streets, there are thousands, on weekends, tens of thousands of young people demonstrating, protesting, and wearing masks, that they are aware of the risk they are taking. We're trying to mitigate it, but still they are aware of the risk, which is the risk of catching a disease, dying for it, bringing the disease home to your friends and family, to your community. Now, when people go to the streets, by taking the risk of their life, this is almost a revolutionary movement, because when people are, ready to die to the limit, to take up a cause, which I think is a worth cause, this is a revolutionary movement. I cannot tell how it will unfold. Perhaps it will fall down and disappear, but no, I think it will continue, because it's something more powerful and more influential than anything I've seen for a long time. But this is still in the making, so we don't know what will happen, how it will unfold. For the time being, where should we start? There is a story which I generally tell my students at the beginning of each term, at the beginning of each class. And I was just thinking that if we go back to class, we will, but an actual class or online in a few months, when I start telling this story, I shall have to tell the story now in a different way, because the events of the last 3 months have already changed the entire logic. Can we have my first slide, which I sent yesterday? Yes, precisely. This is the first slide which I have to shift my, which I showed to my students. First class, beginning of the term, undergraduate students, but I show the same slide even to research students and to master students. Just imagine that you can have a synoptic view of the history of all technologies of all times, from the beginning of history, from the creation of the world till today. And imagine that you can divide the entire span of the history of human technologies into 3 great sectors, or periods, or ages. The beginning, handmaking, artisanal, craft, all that is made by hand, because there are no machines. At the beginning, there were no machines. Everything was handmade. Artisans still exist, but they have been, over time, replaced by mechanical machines with the Industrial Revolution. This is phase 2, the second slot. Mechanical machine making, the industrial age. And these machines, which still are 90%, make 90% of what we use, are now being replaced by a new kind of machine, digital computational electronic machine, which is phase 3. So phase 1 is handmaking. Phase 2 is mechanical machine making. Phase 3 is digital computational electronic robotic making. And let's just assess briefly what is specific to each one of these 3 ways of making. Can we have the next slide? Yeah, this is a basket of French bread, which the French call baguette. They are made by hand, they are baked in an oven, but they are handmade. And if you look at this batch of baguettes, you will notice that they are all similar. They're all baguette, but they are all different. There are not 2 identical baguettes, because if you have seen how a French baker makes them, each baguette is crafted and molded by the gesture of the arm of the baker, which stretches the stem of the baguette before it is put into the oven. Handmaking. This is the way the human body works. We can never repeat exactly the same gesture twice over. Every time we repeat the same gesture, it is always slightly different. You make a line, you like it, you want to make it again, but the next one is never going to be identical to the one you just made, unless you use a machine, a straight edge or a ruler, and then it's no longer handmaking. Think of all the signatures that a human being makes, just a doodle with your name, and every signature which is made by the same person is similar, because it is the handmaking which shows, but they're never identical. They're always different to some extent, because to make them identical, you would need to use a rubber stamp. And then it's no longer a real signature, it is worthless, because it is not marked by the permanent variability of a gestural trace of your body. This is the way the human body works, which is the way the human body is not a machine. Every gesture is different, so everything we make by hand is different from everything we made by hand, even in the same sequence. Every signature is different, every line is different, every baguette is different, because every gesture of the baker that makes it is always different. There can be a style for each baker, which makes that each baguette made by baker A shows that it is his own specific way of making a baguette, but they're still all different. You will never find 2 identical baguettes, unless it is, an accident. Let's have the next slide. Now, these are cookies, in Europe, biscuits. And as you may notice, these are the Leibniz butter cake made in Germany. I don't want to make advertising for the brand, made in Hanover. And as you notice, every cookie, every biscuit is exactly identical to all others, unlike the baguettes, which are all different. Why? Because these are machine-made, industrially reproduced cookies. They are all the same because they were made with a rubber stamp, not with a rubber stamp, with a cookie cutter, with a cast, a mold or a die. They are printed with the same mold, one after the other. Made with the same mold, they are all the same because they are crafted and molded. They bear the imprint of the same stamp. It is a mechanical matrix which makes everything look the same because it gets out of the same stamp. Of course, we didn't invent industrial making to make cookies. We started with, next slide, we started with mechanical printing. It's a printing press in the Renaissance. It's a mechanical matrix which prints identical copies of the same page in every copy of the book. It started at the end of the Middle Ages, Gutenberg's invention, print with movable types, but made all pages of a printed book look the same because they're all printed with the same mechanical cast, a matrix. And today, everything we make, or almost everything we make, is made in the same way. Next slide. Automobiles. The picture is a bit blurred, but you can notice that all the metal parts of this body, of the body of this car, this is printed metal sheets. It is a bigger press, but it is still doesn't print the page of a book. It prints a piece of an automobile, which is made in a factory. It's basically made that way. A washing machine, chair, automobiles as the dominant technology of the 20th century. Identical copies. Now, next slide. Let's have a brief oversight of the technical logic and the economics of making things that way. If you make a mechanical matrix, it costs a lot of money. Imagine a stamp with which you print a cookie or an automobile or a book. Imagine, top left of this diagram, that your matrix costs 100. If you use it only once to make only one copy, that copy will cost at least 100 because you have to get back that amount of money. If you print two copies, you spread the cost of the matrix over two copies. Each copy will cost 50. If you make 4 copies, each copy will cost 25. If you make 10 copies, copy will cost 10. Make 100 copies, each copy will cost 1, etc., etc. To the limit, if you make an infinite number of copies, the cost per copy will be 0. Doesn't happen in real life, but to the limit is the mathematical logic. You spread the cost of the matrix by making many identical copies. This diagram in a single curve, an asymptotic curve, embodies or represents the technical logic of modernity as a whole. This is the way industrial modernity works. This is the logic of mass production, whereby we achieve economies of scale. The more copies we make, the cheaper each copy will be. Mass production, economies of scale of a standardized item of mass production. You make many, you make them cheaper. You make more, you make it even cheaper. The more you make, the cheaper it will be. If you make 1, it's expensive. If you make 10, it's cheaper. If you make 1,000 million trillion, the more you make, the cheaper it gets. Scaling up, making more to make for less. More copies for cheaper copies. Scaling up, the permanent quest for scale, which is the base of industrial modernity. It's important to keep that in mind because computational making doesn't work that way. Electronic computational production works exactly in the opposite way. Example, next slide. Oh, well, this is an embodiment of the industrial logic of modernity. It's a typical skyscraper. Yeah, well, this, no, back one, yes. No, one forward. Next, stop, yeah. This, no, back. Yes, stay there. This is
All of the same.
copy machine we kind of used when I was a ditto machine or a cyclostyle. Never mind. You may have seen them. We are same generation. You may probably have used it, as I did use it. You turn the crank, the mechanical matrix makes identical copies. But next slide. Next slide. This is the printer we all use today. It looks similar. Piece of paper going in, piece of paper printed, getting out. But if you open it to look at what's inside, you will see that the technical logic is quite different. There is no mechanical matrix here. There is no contact. There is no pressure. There is no imprint. There is a laser beam. A laser beam which marks every pixel of the page. Black, white, black, white, black, white. Then the page is printed, gets out of the machine, prints another page, but there is no mechanical matrix. So each page, when it is printed, is a new page. If you make 100 copies, each page will always be a new copy. If you make 1 million copies, each copy will still be a new page because there is no mechanical matrix which is being recycled. Because the same, they are all the same or all different. Compare with, next slide, a CNC milling machine of the kind where every school of architecture in Europe had one in the 90s. So this machine mills a panel, and it takes 20 minutes to mill a panel. And each point of the surface of the panel is individually milled. After you've milled the panel, you want to make another panel. Assuming you make it the same, it will not be faster nor cheaper because each pixel must be printed anew. If you make 100 identical panels, each panel will always take the same time. It will always cost the same amount of money. If you make them all different, no change. The time it takes to make each panel will always be the same. Making them identical, making them different doesn't make any difference unless you need it. So if you need them all different, go ahead. If you need them all the same, go ahead. But don't say that making them identical will make them cheaper because there is no mechanical matrix to use. Even more evident if we look at a 3D printer, next, is a 3D printer making a statuette. There is no cast, there is no mold, no mechanical matrix, no die, no stamp. It is made out of nothing. It is made out of thin air. It is 3D printed. You make a statuette, takes 10 minutes, costs $10. Assuming you're an industrialist making statuettes, and you think, well, if I make 100 of this statuette, I will make them cheaper. Not so. They would be cheaper if you were reusing the same cast, but you're not. Every time that the machine makes a new mold, a new statuette, it's always new from the point of view of the machine. If the next is identical, or if the next is different, it always takes the same time. It always costs the same amount of money. If you think in the old way, you think, I make 1 million, billion, trillion identical copies of the same statuette, I will make them very cheap. No, they will always be the same, regardless of how many you make. Next, robotics. This is the old industrial robot. This is the stupid robot of the 60s. They were designed to repeat the same gesture all the time. From sunrise to sunset, this was meant to replace a worker at the assembly line doing the same gesture. So this is a robot which repeats the same gesture. This is the stupid robot. It's called the industrial robot, meant to do the same gesture all the time. But next, this is the post-industrial robot, the postmodern robot. It's a versatile, flexible robot. Here it is laying brick. it is laying brick in a complex, sophisticated pattern. But the same robot, with a different script and a different program, tomorrow could make face masks, protective equipment, table sets. Doesn't need any training, not an artisan, just need a new script. A script that you can download from the internet. So it can do today, it's a bricklayer. Tomorrow, it can be the day after tomorrow, it can be a textile worker making protective gowns. It's a versatile robot, can make anything so long as a script is, downloaded and used the right script. All this is a name. Next slide. It is called mass customization, the serial reproduction of non-identical parts, the mass production of variations at no extra cost. This is the big difference between the industrial world of mechanics and the computational world of robots and 3D printers. In the old world, if you make more copies, you make them cheaper. In the new world, in computational terms, if you use electronic computational design and fabrication, making more of the same will not make anything cheaper. This is the colossal difference between the world of yesterday, the 20th century, the industrial world, the world of the Anthropocene, as some say, which is dominated by a permanent quest for scale, scaling up, make it bigger. If you make it bigger, you make it cheaper. Make more. If you make more, it will be cheaper. You build a factory, if you build a bigger factory, it will be even cheaper. Permanent quest for scale. But if you use computer-aided design and computational fabrication, scale is irrelevant. Make one, make 100, make 1,000, they always cost the same. From an old world dominated by the quest for scale, scaling up, always bigger, to a new world where scale doesn't matter, to a new economy without scale. Now, just an example to illustrate the difference between the old logic and the new logic. In the old logic, imagine that you have an industrialist and your job, your business is making teapots. And you want to make good teapots, and you want to make good money out of making good teapots. Now, if you know the logic of the modern industrial world, how would you do it? You would try to build the biggest possible factory, making the biggest possible number of identical teapots. So imagine that you design the ideal teapot, the global teapot, the universal teapot, so you can reproduce just one teapot, standard, the standard universal global teapot. Then you make some calculations. You realize that the cheapest place to build a factory to make teapots is Inner Mongolia. I don't know, make it up. So you go to Inner Mongolia, build a humongous factory, but make 1 million teapots per hour. And then you have a fleet of airplanes carrying these teapots all over the world. So they will be, even taking into account the cost of transportation, you make so many, but they are so cheap, but they will still be the cheapest teapot available. This is not a nightmare. This is really the logic of modern industrialization. If you make teapots that way, that's the way to go. But if you 3D print a teapot in a fab lab at the corner of the street, next slide. A fab lab is a small workshop where you can use a 3D printer or any other machine if you are a member for free. If you're not a member, paying a small rental for a machine that you use only for 20 minutes. If you make a teapot on site by downloading a file from the internet, you tweak it, you adapt it, you make it a little bit different. If you need a special teapot, you go down at the corner of the street, you 3D print it, you bring it home. When you need it, where you need it, as you need it. On time, on specs, on demand. And in theory, that teapot will be as cheap as any global standard teapot made in Inner Mongolia, even without taking into account the cost of transportation. In practice, It is not going to happen anytime soon. It's just an example to explain the difference between the old way, concentration of standardized mass production and global transportation, and the new way, flexible, distributed, local, robotic computational making, where you need it, when you need it, as you need it. Now, next slide. That is the first slide. And this is where I generally used to tell my students, we mostly still live in segment number 2. Most of the stuff we use in our daily life is still made the modern industrial way, standardized, mass-produced. But we are shifting to phase 3 because more and more stuff is made digitally and computationally. The computational way of making, the distributed, flexible, robotic, local production is the future. This is what I used to tell. Next time I tell this story, I shall have to tell this phase 3 future for the last 3 months has been our present. Think of what has been working for the last 3 months and what has not been. The artisan at the corner of the street never stopped working. Didn't need to isolate because he's already isolated. The artisan, the craftsman, is a very lonely guy. He works alone in his shop, perhaps with 2 assistants. It's a little family. They don't need to isolate because it's an isolated group. They kept working. They never had to shut down. Robots kept working because the virus, the coronavirus, is not an internet virus. That kind of virus doesn't affect robotics. Robots kept working. What disappeared from our daily life is the factory and the airport, the global network of production and transportation. Factories, airports, they shut down entirely. If we are still, alive and surviving, we owe it to the 2 extremes of the scale, the local, the real artisan, and the computational and the robots. Those 2 kept working. The phase in the middle, the entire backbone of modern industrialization simply shut down. During the worst day of lockdown, from my window just behind the screen, I could still see in the distance the planes going down to Heathrow Airport in London. Not many, but a few every day. And I was wondering, who's traveling? Well, the borders are closed. What is that plane doing? Where is it from? Then I did research where it is coming from, which airlines is. So I investigated, and I found out many of those flights going down to Heathrow, they were British Airways plane, commercial airliners, but they were not carrying people. They were carrying loads of personal protective equipment, hand sanitizer, and face mask from China, from Shanghai, from wherever this stuff is made. I've seen pictures of these huge planes where every seat, not just the cargo, the cabin, every seat, including first class seats, the reclining seats, that cost $300,000 each, they were covered with mountains of hand sanitizer, strapped with, ropes. Hand sanitizer, which cost tens of dollars. But they had it in from China because here made chance to sell planes to pick them up. Now, when that happens, it's evident that there is something wrong. You shouldn't use those planes to carry hand sanitizer. Now, at the same time, it's an anecdote that I've already told. A colleague of mine at the Bartlett teaches computational design. In this shop, his workshop, his Fab Lab is in Spain, in his hometown. And he was down there home when the lockdown came. He couldn't fly back. He had to stay there. And this machinery in his shop used to produce tableware for Zaha Hadid, a subcontractor. Maybe kind of stuff that Zaha Hadid office makes and sells. And the space of a weekend, that guy reconfigured this machinery, and the same robots which on Friday evening were still making table sets for Zaid, on Monday morning they were making personal protective equipment, masks and gown for a local hospital. And they had an airport, nor an airplane to deliver them. They delivered them by bike, just next door. This is what distributed robotic computational fabrication was always meant to do. Where you needed, when you needed, as you needed, on site, on spec, on demand. All the opposite of the old system of concentrating the production of one thing in one place and then carrying it over huge distances. We always said that that was environmentally unsustainable because of the carbon footprint. You cannot carry all this stuff, all these distances, but we destroy the ozone and the carbon footprint is unimaginable. Well, now we don't have to argue that it is unsustainable. It is evidently unsustained. It has collapsed. It has imploded. It didn't work. We have to find other ways to keep what remains of our economy functioning. What better proof that computational making is not our future? It is probably the only future we have. And then, if I still have 5 or 6 minutes, there is another part of the story. Next slide. Next slide, yeah.
We have time, don't worry about it.
Yeah, but I'm almost done.
You are free.
Our first modernist imagined the future in 1925 or 23. It's a famous drawing by Le Corbusier. And this is the image of an industrial city of the 20th century. The same principle. Separation of function, concentration to achieve economies of scale. The modernist city is a city where there is a part of the city where you live, but you do not work, residential. Then there's a part of the city where you work, but you do not live, offices. Then there's a part of the city where you go shopping, or you go to the movies, but you do not work there, you do not live there, called zoning. Residential, production, retail and commerce, different part of the city, each one with a unique specialization. What does it mean? That to go from A to B to C, you must be traveling all the time. We need freeways, subways, etc. This is the modernist idea of the city. In the 90s, next slide. In the 90s, when the internet started to spread and to rise, William Mitchell, then the dean at the MIT, published this little book, City of Bits. It was 1995. The internet was brand new at the time. Didn't even call it the internet. You call it the infobahn, space place in the infobahn. They had a simple intuition. And they said, you know what? With the internet, many of the things we used to do in physical space can migrate to electronic space, to cyber space. We need to go to the bank to do some transactions. Soon, we shall do it online. We need to go to the library to read a book. Soon, we can read it online. We travel office to buy a ticket. Soon, we can do that online. It was 1995. These things were not happening yet, but he anticipated they would. And he was right, because they did happen. It is called despatialization, the migration from physical space to the internet, to electronic space. And his argument was, back then, that the electronic transmission of information is cheaper, faster, more effective, more environmentally sustainable than the mechanical transportation of people and goods. And people told him, it's never going to happen. We don't like it. Even if it is more effective to do it online, we'll never do it because we like to go out, because we like to go to the bank and meet the bank clerk. We like to go to the library because on the way we stop and we drink 3 cups of coffee, and on the way back, a glass of wine. We like to go to the movies because we see people, etc., etc., which is of course true, which is why we like living in cities. But it is also true that in many cases, the economics has already adopted technical change. We don't need to go to the bank branch at the corner of the street so often because now everything happens online. We don't need to go to the libraries as often as we used to because now many books and journals, newspapers and magazines, were all online. So we don't need to buy them at the corner of the street. But what happened 3 months ago is that all of a sudden we were obliged to do everything online because there was nothing else we could do. We had to work online, we had to teach online, we had to read everything online because we were forbidden from going out. Next slide. Next. This is from Bill Mitchell's book, 1995, At Home, the Traditional Way, at home with the sign of the internet. For him, it was the future. As such, that is a future that never happened. For the last 3 months, that has been our nightmare. We have been at home, in an electronic home, doing everything electronically, thanks to the internet, because there was nothing else. The internet kept us alive. So at some point, hopefully, we can go back to do things the normal way, sooner or later and to some extent. But my guess is that after the training we had to go through for the last 3 months, because we had to work online, we had to teach online, we had to buy online, we had to do everything online. We found out that there are many things that, you know what, actually can be done online. From my other window, not the one with which I look at, Heathrow, looking the opposite side, I see the skyscrapers of the City of London, banks mostly, or insurances. For the last 3 months, at night, the lights are always on, shining in the dark. But when I go out and I walk, I can see that there is no one in any of those buildings. No one has been doing any work in any of those buildings for the last 3 months. The entire wiring of a financial network of the world in the City of London has been completely abandoned. These are and have been, for the last 3 months, empty skyscrapers. And yet, the financial markets never shut down. The stock exchange is still operating. All banking transactions are still carried out in the same way. So my guess is that when they can reopen those buildings, they will ask themselves, listen guys, for 3 months we have operated without these buildings. Do we still need them? Now a question for you. If you had to open a new office next month or in 2 months, you start a new business in another country and you have to open a new office and 25 young architects to work for you. Would you think that you have to give to all of them a work desk at the office? Would you dimension the office so that all 25 of them can be working in the same office at the same time? Likely not, because you probably learned that you probably can do with 3 or 4 at the time, and you don't need to have them all together in the same place at the same time anymore. Because for the last 3 months, my guess is that your office was working, but with a skeleton staff in the office. Many were working from home. They couldn't go. Many offices in London have been operating. Sometimes the central office was completely abandoned, but people were still working. I've been teaching classes for the last 3 months. Students have been writing papers, but the building of our university has been locked down 3 months ago, and to the best of my knowledge, for the last 3 months, it has only been inhabited by security guards and by a vast population of rats going up and down, because that's random. And yet, the term has been concluded, students have done good work. Well, there are cases where that was not so easy, but for the kind of stuff I do, teaching online, I never did it before, even though the technology had been around for 20 years. I always thought that was stupid. That was counter to the spirit of teaching. Well, 2 months ago, all of a sudden, I didn't have a choice. I had to do it. I didn't like it. I still don't like it, but I have to recognize that in many cases, it works amazingly well. So my guess is when the building reopens, which it will at some point, we shall go back to classes, we shall rejoice, we shall have coffee, and all these things we can do in a real place. But there are cases where I will probably tell my students, listen, guys, for the next class, we meet on Zoom. Because for the kind of stuff I have to tell you next week, you know what? Zoom is better. And in 2 weeks, we shall meet in class. So we have learned that it can work. And we will not go back to where we were after having had this, demonstration of the efficacy of electronic communication. And by the way, we were complaining 3 months ago that all our transportation of people and goods was destroying the environment, was environmentally unsustainable. Well, for the last 2 months, no one has been going anywhere. So the carbon footprint, my own carbon footprint has gone to zero. I haven't gone anywhere. I've been here all the time. And so if we travel a bit less, and if we use the internet a bit more, I think the environment and our carbon footprint will probably profit quite significantly from it. Yes, some airlines will go bust, and some airports will remain unused, but we always said that this colossal growth of global transportation was unsustainable. Now we don't need to argue that anymore. It is not unsustainable, it is unsustained. It has collapsed under its own weight and the weight of the contagion, unfortunately. So this will have direct implications, I think, for what we do as teachers and what you do as designers, because there are building types which, in my opinion, in the next months or years, will not be in such a big demand. If I had to make an educated guess on the type of commission that people like you may receive, is not to build a new skyscraper with offices, is to take a skyscraper with offices built 3 years ago and convert it into residential flats. Because people will need bigger apartments, will be working from home, more from offices. So we shall need fewer offices and bigger apartments. That's, if I were, in charge of a big supermarket chain, I would probably not worry that much about the logistic of restocking the shelves. Because many people like me have been using home delivery. And at the beginning it didn't work, and now it works, so they actually improved it. But there is a significant difference between cities, which are designed for us to go out and look for stuff, and cities which will have to be designed for us to receive stuff. The logistic of delivery will require technology, but also a different urban design. Because ours for us to go to the grocery, not for the delivery guy to leave my, food on my doorstep. So it's a complete redesign of the urban environment, which we have to consider, because we have learned, well, I like shopping, going to the grocery, to pick each apple one by one and each banana one by one, because I want to see if they are ripe. And when I look at the meat at the counter, I can tell, no, today doesn't look good. I will not buy it, come back tomorrow. Cannot do that online. So I would still like to go back to the groceries. But to be honest, I cannot do that every day because I work. So the comfort of receiving my daily food in a bag left on my doorstep at 10 p.m., something which I've learned now I can do, I never knew it. I never even thought I would do it because I'm an old man. I'm used to go to the bakery and buy the fresh bread every day. But now that I know that I can receive it on my doorstep, you know what? I will probably keep doing it even when normal life restarts. So there are things that we have learned to our detriment during the emergency, which we shall keep doing even when we go back to normal. And this will be big changes for your profession, for the kind of stuff you build, for my profession, for the kind of places I teach. Questions?
Fantastic. Thank you very much for your explanation. Somebody sent us a question about your graphics. Maybe you can see the timeline.
I see, but someone. Yes.
The question
Let me
about
see.
question about the architect roles and also architects' missions in our architecture field, let's say. You mentioned the first part are artisanal variations, and second one industrial identical copies, and the third one the digital age. And then
That's right.
the question about the architect roles. First of all, he or she is asking about starting from the Anatolia 12,000 years old, says architect and builders combine the same person as a man, engineer,
Exactly.
and an artist at the same time. Design and build. He does or she, or he does that time. There is no she. He executes what he designs as a builder. Industrial time, the starts from the man, and then second period of the 20th century, woman involves the field. The architect and builder divided the two person. Also, engineer and artist, it's not the same person, the only architect. There are some architects close to the engineer side, other one is the artist's side. And the digital age, again, reunited, let's say, architect and builder. There is no gender free and a race free, and I'm talking about there is no man or woman, and gender free and also race free. And there are some ways the hidden agenda, more engineer and artist, let's say.
That's a beautiful diagram. Yeah. Who did it? Someone who just sent it to you?
It's the name is Ozan Ertuğ. He worked for the GAD, and then he is a freelance architect right now.
This was not time during my talk, right? This was prepared in advance.
Okay, and then handcrafted and mass production, theoric and other one. You know, today he's asking the question about we spent 25 years already in 21st century. He's asking the question like the new identity about the archineer, because the design and build time, architect as a builder also, he creates and also calculates the old buildings pieces, but the industrial part divided the couple of pieces, the engineer and artist, and we know the architect never ever calculates his building structural system. And digital time may be, or we assume, combine, also reunite the architect and builder together. Maybe we call that again as a new name. He calls the archineer, I don't know. And what is the next, in the future from the 2025, or 12,025. According to, he mentioned the Hallucine time till the 1784, and then the Anthropocene's time.
Yeah.
Maybe, yeah. I'm trying
No,
to.
this is a beautiful diagram because
You like that? It's good.
It's very good. It's very good. Congratulations to whomever did it. Send it to me when you're done. Send it an
Sure.
email to me so I keep it
Sure,
because
sure.
I didn't include the role of
Yeah.
the architect in my presentation,
Yeah.
but it is
Yeah.
true, absolutely.
The question is about the architecture roles, the next in the future, next 12,025 or 2025, let's say.
Yeah, that's a long shot in the future. But looking at the diagram at the beginning, the architect and the artisan were not separated, as there was no separation between the artisan and the artist. By the way, in Latin, and hence in French, English, etc., artisan and artist, it's the same term. Art, artisan, artist. In the Middle Ages, there was no difference between the artisan and the artist. It was just a way of making stuff. Between the low artisan and the expensive artist that started only in the Renaissance, when the two terms started to have a different meaning. Tried and managed to separate themselves from the artisan, the guy who actually makes stuff, to the artist, the guy who makes art. So he's cleaner, makes a better living, earns more money, and he's a jet setter, etc., etc. This separation happened in the Renaissance with the famous artists from, Raphael, Michelangelo, etc. They were the first artisans who, since they didn't make chairs, but they made paintings, they were paid more and they made a better living and they met important people. So, but in the social scale, they moved up. But at the beginning, in the artisanal way of making, the artisan made a building just as an artisan would make, a chair or a table. They didn't need a design. They were teams of craftsmen working together. When they started even an important building, they didn't have a blueprint. They didn't have a design. They just had an assignment or a task. They were told by the owner, do that building, and they received guidelines, meaning how many rooms, or if it is a temple, how many columns on the front, how many on the sides. And that was it. Then every team of artisans, when they came to the site, they fixed problems on the fly. It was conception and realization in the same person. This way of making, which was collaborative and anonymous, held good till the Renaissance. Again, look at the masterpieces of medieval architecture in Europe. The Cathedral of Chartres, for example. It's a famous building. It's in all history books. But who built it? Do we have the name of a designer? No, we don't. There is no name for a designer because there was never any design made. It was a job description. It was a plan. The cathedral would have 3 naves and 8 bays and 2 towers on the west front. And then people started building, and every team of workers brought to the site their own expertise, and it was a permanent work in progress. This was the organic, traditional, artisanal way of making. Then in the Renaissance, the new artist came up with a different idea. He said, no. I'm not going to the site and lace bricks or carve woods or break or, cut stones. Let's do it another way. I make a drawing, a clean drawing, plan, elevation, and section, proportionally drawn to scale. I put my name on it, and then a rubber stamp, they didn't have it, and a signature and a date. And then you build it without any change. And don't change it or else. That was the separation between design and making. That was the invention of our profession, not as maker of buildings, which we don't do, as maker of drawings, which is what we do. We make a drawing, we don't make the building. Thinker doesn't make, the makers do not think. Separation of task. We have the idea, we put it on paper. Give the paper to the builders, they build, but they do not think. They are not allowed to change it. This is how we transfer our idea from our mind to paper to stone. How we transfer the intellectual authorship, the intellectual ownership from our hand to a building. Architects say, that building is mine. I don't mean that they own that building, unless they own it, but that may happen. They mean, I own the idea of that building. I own the building. That building is owned by Mr. So-and-so, but I own the idea of that building. So if you take a picture of it, you must put my name and my copyright and ask for my permission, because it's my idea, which is embedded in that building. But that we do by making drawings. We make the drawings, we don't do the building. Through the drawings, our idea is transferred from our mind to the physical building. That is the modernist idea of a building. This is the idea that created Le Corbusier, Gropius, and Mies van der Rohe. They are creators. Their creation is put on paper. What happens to that piece of paper when it becomes a building is legally separated. According to the global rules of our profession, there is a firewall separating our liability, there is a contract, there are contractors, etc., etc. We are paid for the drawing, someone else is paid for the building. And then there is a complicated system of negotiation whereby we try to extend our control to what the builders do, because as we know, they want to simplify, and so it's a permanent fight for the designer to maintain some control on the process of building when it is out of our hands. Now, phase one, we didn't exist. Phase two, we existed as makers of drawing. Phase three, which is what is happening now, through computation, conception, notation, representation, calculation, and fabrication happen in the same machine. It's all a digital notation, which allows us to go back to the domain of making, which we had previously abandoned. Which, by the way, you can see if you go to any school of architecture. When I was a student, there was no physical making in schools of architecture, except for making maquettes, but that's a part of the notational process, that's design. Of architecture today as a workshop where students make physical stuff. They make chairs, they print stuff, they mill, they bend metal, they make pavilions. They are actually going back to making stuff, because in the computational domain, notation and fabrication are no longer separated. Why? Because the same machine does both. The same screen, which you use for notation, which you can use for calculation, is also the tool we use for fabrication. So from the same screen, we can transition from conception to representation, to calculation, to contract, and to fabrication. It all happens on the same screen. It can all be managed by the same team. And this is the spirit, the new spirit of the game. It's not the architect in the modernist way, it's something else. It is more participatory, it is more collaborative, it is more collective, but also, not only we have to collaborate with many more people, we have increasingly to collaborate with artificial intelligence tools, which are capable of making independent decisions. Increasingly, the titanic role of a modernist architect, like in a novel by like in The Fountainhead, famous, the architect who, the Titanic inventor, and we will see a building which is exactly as he had put it on paper, and there is a little decoration put on the front of that building, like Howard Rourke in the novel by Ayn Rand, Fountainhead. You can go there and blast it because that's, someone betrayed your idea. This, well, it was an absurdity in 1952, or whatever when the movie and the novel were written. But it is now technologically unsustainable. We will use more and more of computation because it makes economic sense. The tool will push us inevitably to a more collaborative, to a more interactive, to a more data-sustained process of design. This is, I think, what is going to happen. And in this new techno-social environment, the Titanic star architect, which is so famous today, will probably, well, it will still exist because this paradigm do not disappear overnight. And some very famous icons around the world will still made by Titanic star architects, but that's probably 1% of the global architectural production. The rest will be done in a fairly different way. What else?
Thank you. Thank you. And the next question. We reach a point where some architects in some
it's exaggerated or tries to deliver envision envelopes also on this matter. Well, yeah, I know that happens. It happened in some even famous building by famous architects and people I admire. In the 90s, the new technology for iterative design and fabrication allowed us to design shells with very sophisticated shapes. But these shells were not self-sustaining. For example, in a famous building by Gehry, the shell, which was designed with CATIA by the spline modeling, which was a masterpiece of architectural design and an example of very intelligent use of technologies. So it's admirable. But at that point, it was pure geometry without any structure. It was a complete separation between form making, what we see, these fantastic shapes, a masterpiece of advanced geometry and of computational fabrication. Masterpiece. But it didn't stand up. So to make them stand up, they needed a very traditional structure built behind it, invisible, to which all these panels are nailed or welded or whatever. Complete separation between the geometry of the shell and the structure, which was almost, an afterthought, something that was needed to make that shell stand up. It's painful if you are an engineer. If you're an architect, you really don't care because the Guggenheim Bilbao is famous for the shape that you see, not for the banal engineering structure that you do not see, which is just necessary to make it stand up. Now, if you are a structural engineer, of course, at some point you would want a structure or a shell which is self-sustaining, where you can optimize the use of materials. You see, it's not just a sculpture, it's also something that, if you make structural sense, not at huge scales, but experiments on optimization of self-sustaining structural shells are happening in many schools. So my guess is what is happening now at a small scale will soon be happening at bigger scales. So there will be a merger between the geometry, this is what architects typically do, and the structure. It will no longer be a separation between the shell that you see, the structure which is hidden behind, but something which will be structure and shell at the same time. When that happens, it will be a bonus for both the architect and else.
Next question. Thank you very much, Mario. It's coming up. Rumeysa Güzel is asking, I have a question, Mr. Carpo. In today's digital architecture age, is the architecture approach is getting better by making more uniform global structures such as skyscrapers and residences, etc.? Or is the architecture approaches in the old times were more unique style and suitable for regional conditions?
Well,
Young
one of the
architects,
spirit of the story, the
young
spirit of the
architects.
story I told is in the modernist paradigm, you want to standardize in order to mass produce, to achieve economies of scale. But using computational tool, you can mass customize. So you can make each item different without having to pay a supplemental cost. So the idea is that in the modernist spirit, you want everything to be the same, because if you make it all the same, it will be cheaper. So even if there is waste, what you waste by standardizing is more than compensated by what you save with the economy of scale you embed into the production system. This is a logic which, perverse as it may appear, made perfect sense in 1958, for example. If you were an architect in 1915, at maximum standardization to maximize economy of scale in mass production of every component. Today, we no longer need to achieve economies of scale if you use digital technology, because in many cases, digital economies of scale no longer apply. We can make everything as different as it needs to be without having to pay more for that. In theory. Practice, it doesn't really work that way. But in theory, this is where we are going. So we can make everything different or as different as we want it to be without having to pay a supplement to get it. So soon, everything can be different if we need it to be. Now we can do it. It's more expensive. Soon, this supplemental price, the cost of difference, the tax on variation, this will disappear because the new computational technologies do not work that way. So that's good.
Next questions, and we have more than four, but we have chosen the 4 questions for you. We would like to keep you alive. There are many questions, Mario.
What you mentioned is almost collapsing of physical space over our home. And we point out we may have to convert big office building into larger apartments. This pandemic will not last forever. You think that will affect this much of our future daily life? We forget and turn back to some habits sooner. Yes, that's a good point. I mentioned that. This is an emergency, and it is, of course, painful. And we all hope that we shall soon go back to life as we like it, or as much of it as we can. But my argument was that having learned during the emergency that some of these technologies work so well, even when we do not need them anymore, we may want to keep using them because they have proven their efficacy. The example I gave was for my own job of teaching. When I go back to having every class or every meeting in a physical building, I will probably keep something online because I have evidence now that for some kind of classes, Zoom works better than a lecture theater. And when people invite me to give a lecture in Australia, which takes 28 hours of flight, I will probably tell them, listen, guys, it's a long flight, costs you a lot of money, costs me a lot of time. It costs the environment a lot of carbon footprint. Let's do it on Zoom. So it's cheaper for you, it's better for the environment, and I can still go out in the evening and have a walk without taking a plane. So my guess is that having learned that some lectures on Zoom can work so well, in the future, I speak for myself, I will still like to do some travel, but probably not much as I used to. And in many cases, perhaps not for lectures, but for meetings and committees and juries and panels, I said, no need for 6 persons to travel to Rome, to meet in Rome for 2 days. Let's meet on Zoom, guys. It'll be faster, it's cheaper, and it works just fine. So in my opinion, having learned that it can work, we will want to keep it working even when we don't have necessarily to keep doing it, as now we have no alternative. We cannot travel, we have to do that. But my guess is that when we go back to normal life, what we have learned during the emergency, some of it will stay. And then in many businesses, it's just a matter of rationality. Banks will have learned that they don't need many local branches because they shut them all down. Well, last 2 months, and everything kept going on just fine. So that means that they probably can shut them down forever. The same for the office buildings, etc., etc. So there will be a evidently when we can go back to doing things normally. I'm hoping that soon at some point I will put this computer in a box for 2 weeks and don't touch it anymore for at least 2 weeks. And that's human, that will happen. But then when we go back to normal life, rationality will take over. And having had the demonstration of the efficacy and the performance of electronic communication, we shall not want to do without it, because it has proven its efficacy. So we shall keep it, some of it at least. Next. Is there a specific reason of early modern and contemporary digital? I'm focusing on contemporary digital because it's inevitable. I mean, it's what we are doing every day. It's our daily life. Why did I start with early modern and Renaissance? No, that's
Sana bir soruyu koyarsın. Hemen siyahı koy.
Are you saying something? No. No, that's a coincidence. A reason why my first books are on early modern Renaissance. It's just that I was in a school where early modern Renaissance was a specialty of the school. So if I had been in a school where the specialty was Byzantine architecture, I would probably have specialized in Byzantine architecture. That's a coincidence, just an accident of life. Next. Is there a next?
Yeah. We have more. Don't worry about it.
No, but in 10 minutes I have to go.
All right. It's okay. It's up to you.
Perhaps.
I have more questions.
Many physical spaces will not be used. Offices will be abandoned. How can this building be attached the new age cities? I don't get the last phrase. How can this building be attached? What does the last part of the question mean? Do you get it?
Yeah, question about many physical spaces will not be used. Offices, schools, abandoned. Okay. Yeah, she's asking about the many buildings. It's a kind of build it up, not necessary. It's going kind of it's industrial time. We can't use then the next in the future. There are many junk architecture. There are many junk architecture. Only they build it up only one function. There is no multifunction any opportunity to transform them. For example, you can switch, you can change, you can transform any some very spatial industrial buildings, for example, or some governmental buildings. And
I get. So it is
evident. How can we transform them? Also, how can we create for next generation? Maybe we should use about them the maybe multifunctional, flexible, transformable, easily.
Absolutely. Now the paradigm of an organic, multifunctional city is the pre-industrial city. The pre-industrial city had the necessity to separate function. Everything was happening in the same street, sometimes in the same house. The typical house of the medieval artisan or merchant in Europe, I presume even in your part of the world, the typical merchant or artisan at the end of the Middle Ages, in my hometown, for example, I presume even in yours, house where there was a basement, where he kept his raw materials, on the ground floor, under the portico, he had a window where he showed the stuff he made. His workshop was the back. His own residence was the first floor, and his apprentices working for him lived on the top floor. So the entire production, consumption, and residential system was under the same roof. This is the way Venice was built. And you see it better in Venice because Venice is frozen in time, so it still looks as it did 400 years ago, mostly. Or if you go to historical cities in Italy or Switzerland or France, where the infrastructure of the industrial city was made for this huge concentration of specialized functions, which we don't need anymore. In my opinion, the post-industrial city, the computational robotic city, could be very similar to the pre-industrial organic artisanal city. We're talking about digital craft. So I'm thinking that Venice, for example, would be the ideal city to build a computational robotic environment where I could have an office on the second floor, someone could have a fab lab with robots at the corner of the street, the market is not far away, and the school is in the next block, and people don't need to ever walk more than 1 mile from whatever they need. They don't even need bicycles because in Venice you have boats, just like in Istanbul, I think. So recycling a pre-industrial city would not be a big deal because the pre-industrial city is more or less what we need today. The problem is that most of our infrastructure was made, and this is still being made perversely, for industrial city based on separation of specialized functions, which is what we don't need anymore, particularly because many of these functions don't exist anymore. The skyscraper, the glass skyscraper, with the name of the bank on the top, was a big idea in 1958. It worked very well. But I don't think you will build any of that in the course of the next 10 years. Tell me if it happens. But in my opinion, this is not the market of the future. This is the market of the past.
Thank you.
And
We have, Mario, we have incredible, many questions to you.
Choose one.
We got one. Choose one. Choose one from Gokhan Karakush. You know the Gokhan? He sent us the question.
Oh yes. I met him. Yeah.
If you want to, we have a couple of many questions to you. But the last one.
The Ottoman system offers less drawing and more oral transmission and building team. Drawings are very rare. It has the potential of Eastern ways of building relying less on the drawing. This Ottoman system, of which I know nothing, comes on what I know on the European way of building before the Renaissance. So, for example, the transitional guy is Brunelleschi, who built the dome of the Cathedral of Florence, but he still built it without drawings. He was an artisan. He went over the scaffoldings and he said to his workers, today you do this. He said, and tomorrow what do we do? He said, I'm not going to, because tomorrow I want to be here and I will tell you what you have to do tomorrow. I'm not going to tell you today, because otherwise tomorrow you will not pay. So the majority is paper, because if he put it on paper, he was afraid people would build without him. So he did it the old artisanal way. A few years later, Alberti said, listen, it's possible to do it that way. It's time consuming. I don't want to spend 18 years for each building I build. I will put it on paper. I might put my name on it. And then you will build it, and it will be a celebration of my idea, because everyone will know that the drawing was made by me. This is the tipping point between the old way, informal, collaborative, oral, and the new way, based on written documentation and drawing with a date and the name and the signature on them, the invention of intellectual ownership. That's the invention, which starts around that time. All pre-industrial, pre-modern system in the West and in the Middle East and in the East and in Far East, for what I know, which is very little outside of Europe, they all work in similar way. because orality and collaboration was the only way to build. When Europoint invented a new way, which became a global standard a bit later. Relying less on drawing, yes, this is indeed already happening. If you use building information modeling technology, you don't really make drawings, you do 3D models, which can change all the time on a participatory collaborative way. Some of my colleagues who work on BIM tell me that a BIM model is more or less like a medieval way of building, except that you don't really build a building, you build a model in the same collaborative, anonymous, participative, or participatory way, in the same way as medieval craftsmen built a real building. Today, engineers using BIM build the model of that building. There's a big advantage on that. The model is wrong. On the screen, you can remake it, costs nothing. If the building is wrong, it will collapse. And so that's a big catastrophe. So we have a big advantage on medieval builders. We build a digital model. We can remake it every time, anytime we need it, anytime, as long as it takes. The Middle Ages, we didn't have notation, so we worked together on the real building. So if we made a mistake, the building collapsed. If we make a mistake, the model collapses on the screen. It's not a big deal. Shall be made better tomorrow. This is the big advantage we have. But the spirit, logic of the game, the spirit of the game, but we work together on a model. I know how to make that part. And tomorrow you know how to make that part. And little by little, we shall make the model together. This is the logic whereby every building was built in Europe before the Renaissance. And this is the logic that building information modeling is bringing back to our profession. And this has to be my last word, because in 4 minutes I have another meeting.
Mario, you are like a dynamic person. You do many things at the same time. And then, but every day, the 24 hours, we should leave to you some time to do other issues. And
Yeah,
thank you very
cup of
much.
coffee.
We really appreciate that. Thank you very much. You're amazing.
No, thank you for calling me. I hope it was understandable.
You are really important for our time. We really inspire from you. Not only me, also the young architects, young students. Thank you very much for all of
Thank
information
you. And let's
explanation.
meet on some beach. Let's meet on your boat as soon as possible.
Absolutely.
Thank you very much.
I'll send you the questions, especially the charts.
Oh, yes, yes.
Thank you very much. Have a nice
See you soon, hope.
evening.